I, Nilanjan Adhikari, student of the Department of International Relations, Jadavpur University, welcome you all to the workshop on research methods in international relations organized by Jadavpur Association of International Relations. Today, I am honored to introduce Dr. Shoumodip Chattopadhyay, Associate Professor at the Department of Economics and Politics, Vishwabharati University. He has contributed numerous research papers to reputed journals, authored books, and book chapters. He has also presented research papers at several international and national conferences. He has completed multiple impactful projects. He has been awarded Raman Postdoctoral Fellowship for the year 2014-15 in USA and Commonwealth Academic Fellowship 2013. His research interests are urban governance, urban finance, urban politics and policy, urban studies, and participatory development. We welcome you, sir, and would request you to please take over the session. Thank you.
Thank you, Nilanjan, and good evening to all of you. I think I am audible to all of you. Am I audible?
Sir. Yes,
sir.
Great.
Yes, you are audible.
Okay. So, at the very onset, I am thankful to JAIR for inviting me to this workshop. And I'm also assuming that some of you are familiar with some of these basic statistics, which I'm going to share with you, because since many of you are from bit different backgrounds, so I'll be trying to as non-technical as possible, and mainly my focus will be on to discuss or to make you familiar with some of the most commonly used statistical tools which are used in research all across the different spectrum or different subjects of social sciences. So let me first share my screen. Please confirm whether you can view my screen or not. Can you view it? My screen?
Yes, sir. Yes, sir. It's visible.
The title of my today's presentation is Statistics for the Social Sciences, a primer. Let me begin with this basic submission that the statistics is nowadays used in almost all fields of human knowledge. We use statistics in economics, of course, and political science, planning, medicine, and also different science subjects like physical as well as natural. And in a typical textbook framework, the statistics, it actually is defined in two senses. One is, of course, the plural sense, which deals with the numerical facts and facts, which are collected in a systematic manner with a definite purpose in any field of study. And the other method is, and the other sense, or the lens is singular sense. According to this particular sense, statistics is a kind of science which comprises of methods which are used in collection, analysis, interpretation, presentation of numerical data. So in today's presentation, I shall be mainly focusing on a bit of collection, analysis, and of course the interpretation and the presentation of the numerical data with which we generally deal with. So let me start with the collection and presentation of data. Now, as we know, data means any numerical figures, facts. So these are mainly collected from two sources. One is primary data and another is secondary data. And the secondary data may be taken from some government agencies, or in some cases maybe some private agencies, and may exist in published or unpublished form. Typical examples are Census of India, which gives some valuable information on our population, and also the NFHS, National Family Health Survey, which gives us the information on the conditions of health. We also have NSSO, National Sample Survey Organization, which publishes data on various issues. And these are some of the government sources. From that, there are many other private sources which also collect and share some of the information. For example, you must be aware, many of you, because recently, in recent times, there has been widely use of the data which is on employment, unemployment, state of employment and unemployment scenario in India, which is published by the Center for Monitoring in Indian Economy, which is a private concern. And apart from that, these are all the secondary sources of data. From that, we have also primary data, which are generally collected primarily keeping into the needs of the given inquiry, and these are called the primary data. That means you have a specific research objectives, and to examine some of your research objectives in a systematic fashion, you collect data on the basis of some kind of primary survey. Now, there are two, now when I'm concerned about this collection of data, now there are two specific methods of collection of data. One is known as the method of complete enumeration, and the other one is known as the method of sampling. Just consider this particular example. Suppose you are interested to examine the average income of the current full-time employees at Google. Now, there are basically two ways through which you can study this kind of issues. One is you can get access, or you can try to get access to all the full-time employees of the Google, and then you can calculate their average income by certain statistical methods. Okay. Now, the average income which you calculate on the basis of all the full-time employee of Google, in statistics we call it parameter. This is very important. And also, the other way to address the same objective is to do a kind of random selection or subset of employees and then calculate their average income. In statistics, we call them statistic. So you have to remember this particular fact, that because in many research papers you may, which are obviously dealing with some quantitative methods, quantitative analysis, you may find the action of parameter and statistic. So parameter basically relates to the population characteristics, whereas the statistic relates to the characteristics which corresponding to a particular sample. Now, there are certain misconceptions which we should be wary of, or which we should take into account while doing this kind of complete enumeration and sampling. Now, first is there is a conception that when we try to conceive of population, or when we try to think of a population, then a population is a kind of large in nature. That means there are large number of data which are included in a particular kind of population. But in practice, a population does not need to be a large. For example, maybe I am interested to study or I am interested to know the average heights of the students in a particular class. So in my class, say. So if that is the case, then definitely the population will be the number of students which are attending my class. So it may happen that there are only 5 in my class. So in that case, the population will be 5. And second important aspect regarding this population is researcher generally they defines the population either explicitly or implicitly. Now again, let us consider a particular example of, say, suppose you are interested to analyze the incidence of depression among the adolescents. Okay, so in that context, in order to address your research objective, suppose you decide to do a survey on 15-year aged boys or girls who are coming to a particular mental hospitals in a particular city. Okay, so in that case, your population will be all those 15 years, all those boys or girls who are actually 15 years old and who are coming to the particular mental hospitals. Okay, so that means you are actually defining your population quite explicitly. Okay, but this leads to a problem of improper sampling, because in many cases there are instances where samples are not necessarily good representations of the population, because what theoretically what we generally try to do is to get some idea about the population parameter on the basis of our sample statistic. That means maybe in practice it is not always possible, or it is not always feasible rather, to look at the parameter or to look at the, or to survey the entire population, or to adopt a method of complete enumeration. So that's why we are going for sampling. Okay, so in that case, your idea, there are many statistical methods of doing this. Your idea is to get some or your objective is to get some idea about the population parameter which are on the basis of the sample statistic. Okay, so if that is the case, that means if you want to have a very good idea about the population parameters using the concept of, or using the, taking the help of sample statistic, then definitely this process will be beneficial in some sense if your samples are good representations of a population. Okay, but if you define your sample in this way, explicitly in this way, the example which I have just discussed, then in that case, it may be the case that the samples may not necessarily good representation of population, because when we are considering the incidence of depressions among the adolescents, then definitely by adolescents, generally there is the age group of 13 to 20. So if we concentrate only on the 15 years age group who are also coming to a particular mental hospitals, then that means we are driving down our population. So in that case, what could be the other option? The other option would be to broaden your population in a sense that you can consider those who are in the age group of 13 to 20 and who are actually coming to the different hospitals for checkup, or for some kind of taking some kind of advice. So this is basically the kind of thing. This is the graphical representation. That means this is your entire population, and you are considering a particular sample from that population. So if you can calculate some sort of statistical measure on the basis of all these observations, then that particular measure is called parameter. And if you are considering only these three objects or these three sample observation and calculate any statistical measure based on this, then that is known as the statistic. Now, obviously, there are several ways through which the researcher can select samples. Now, it's a huge literature, so I'm not going into the details of everything. But most commonly, these are the three important sampling techniques which we generally follow. One is, of course, as you know, the random sampling. Now, by this particular concept of random, when we consider random in statistics, then random means which is not purely haphazard. Okay, because in statistical sense, random sampling means every member of a defined population has an equal chance of being selected into a particular sample. And in that case, that selected sample will not be systematic. That means there is a very subtle distinction between a sampling which is random in nature and the sampling which is non-systematic in nature. For example, the idea or the example which I have just given, that the mental depression among the adolescents, you are considering 15 years aged boys or girls who are visiting the mental hospitals in a city. So that is a kind of example of a systematic sampling. Okay, why I am calling it systematic? Because here we are systematically specifying the age group of the adolescents whom we are going to survey. Okay, so this is a kind of systematic sampling. Okay, so select samples, but in case of random sampling, that the selected samples may not be systematic in nature, and that is why it is said that the randomly selected samples, they may differ from the larger population in some important ways. And these differences, which is very important, is the fact that these differences are due to the chance rather than to a systematic bias in the selection process. So this, and there are various ways of doing this random sampling. There is a random number table which we can use, or we, the students of economics, use to do a kind of random sampling, but those are purely those are the part of a very larger literature on sampling. So I'm not going into the details of that literature, but random sampling means you can choose a particular unit from a population which has equal chance of being selected into a sample. Okay. Apart from that, we may also resort to a sampling process which is known as representative sampling. Okay. Take the example of suppose you are, as a researcher, you are interested to investigate the average annual income of adults in Kolkata. Okay. Now, definitely, so here what is the population? Population is adults in Kolkata. Okay. Now you have to do because it is not feasible practically for you as a researcher to survey all the adults in Kolkata. So you are taking the help of certain kind of sampling technique. Now here, what one possible sampling framework could be the representative sampling framework. Okay, and while considering this representative sampling framework, you have to keep in mind that adults in Kolkata, they represent different subgroups. For example, there may be some male, some female. There may be some adults who are belonging to the general category. Those who are not belonging to the not belonging to the general category. There are some people who are retired. There are some people who are working. There are some people who are regular salaried, and there are some people who do not get regular salary. So all these kinds of different subgroups which are there within these population adults in Kolkata. Okay, so then how can we can you make this sampling representative? Suppose you decide to choose, say, do a survey on, say, 300 households or 300 adults. Okay, now you also know that in Kolkata, say 55% of population is male, 45% of population is female. So while choosing your sampling, you have to do the sampling in such way so that in your representative sampling, that means in your 300 total number of sampled observation, 55% of them should be male, 45% should be female. Similarly, it may happen that among the adults in Kolkata, there may be say 40% is general, 20% is SC, 15% is ST, and so on and so forth. So if that is the proportion of their representation, then obviously while you are doing the survey or while you are selecting the adults in Kolkata, then definitely you have to also make sure that the sampled units, they also represent the same kind of percentage figure. Okay, so obviously, as you know, or as you can easily understand the fact that this process is definitely costly, this process is definitely time consuming. But once it is done, that means if you can able to make your sampling observation representative of the true population parameter, then the true population, then definitely it will increase the chances of being able to generalize the results from the sample to the population. Because as I mentioned, while you are doing this kind of exercise, then your basic objective is to understand the nature of the population parameter with the help of sampling statistic. Now, if that is the case, then definitely better is your representative sampling scheme, better with the chance of getting good results. You be or you will be able to generalize the results from your sample to the population in a much more efficient way. Okay. Third sampling frame which we researchers generally use is known as the method of convenience sampling, and this is basically again, if we consider the case of, if you are interested to study the achievement level of 8th grade students, then as a researcher you may decide to survey 200 students from, say, 2-3 nearby schools which are nearby schools to your residence or maybe to your districts or something like that. Okay, so this is known as the convenience sampling. Now definitely kind of sampling is again not very bad, as long as the output that you are producing, they are basically the results which you are producing, they are not biased in nature. That's the output which you are going to get. If they are not biased, then definitely you can you are very or you may resort to this kind of convenience sampling. Okay, and at the same time, while doing the random sampling or the representative sampling or the convenience sampling, you have to always keep in mind that problematic sampling methods can lead to a faulty conclusions. Okay, one very classic example is the diagnosis of heart disease in women. Generally, it is believed that the incidence of heart diseases are relatively less among the women. So whatever the statistical analysis which have been done on this case of heart diseases, mostly they consider the samples which are male dominated. Okay, now if this is the case, then definitely the problematic sampling method can lead to a faulty conclusion, because it will not be very much helpful for addressing the health problem, which is specifically related to the heart among the women. So when doing this kind of calculation, or while considering this kind of method of collection of data, you have to be very much careful about the method of collecting data. That might be, as I mentioned, that might be random sampling, that might be representative sampling, that might be convenience sampling. Now, in either of these cases, the information which one can gather, there are basically three methods. One is the questionnaire method. Again, there are various issues which we need to keep in mind while framing the questionnaire. Apart from that, there are interviewer method, and also there are the method of direct observation. Okay. And after doing all this kind of thing, one crucial aspect, we generally do not pay that much attention, but we should pay enough attention to this particular aspect, which is the scrutiny of data. That means you need to detect the mistakes in data for preserving the integrity of any data analysis, which is in statistics it is known as the process of data cleaning. Now, these are as far as the collection of data. Now, these are very basic ideas which I have just discussed. So that is the component of the collection of data. Now, suppose you have collected data. Okay, now you have to analyze those data. Now, while analyzing the data, you need to be you need to understand the nature of the data. Now, whenever we are considering the nature of the data, generally there are two types. There are different ways to look at the nature of the data. One distinctions which is generally made in statistics is the distinction between frequency data and the non-frequency data. Non-frequency data, again, it is basically the values of one or more variable which may be given for a different periods of time. For example, if you consider the population data, which we generally get from the census, it is done every 10 years. So you have, say, if you consider West Bengal, so you have the data on West Bengal from 1901 to every years up to 2011. So that is basically a kind of non-frequency data. Or you may consider the state-wise cotton production at a particular point of time. For example, you may consider, say, 2015, and then you have the data on cotton production of 16 major states of India. So that means here, these are the examples of non-frequency data. And apart from that, we have also another type of data, which is known as frequency data. Now, these distinctions are very much important because on the basis of these distinctions, the measures which we are going to discuss a little bit later on, you will see that the measures will be different on, or even the graphical representations will be different on the basis of this kind of distinctions which are related to the nature of data. Now, frequency of data means, again, here rather than individuals, sometimes we are interested in the characteristics of the groups. Okay, suppose you are studying the scores of students in social sciences. Okay, that can be a frequency data. Again, suppose you are considering, again, the examples which I have just given, the adult income. The annual average income of the adults in Kolkata. Okay, so here you can actually have certain amount, some kind of groups, and then or some kind of income ranges, and then you can always find out how many people or how many adults in Kolkata they are falling within that particular income range. So that is basically an example of frequency data. Another distinctions which is very important from statistical sense is basically the distinction between attribute versus variable. Okay, what are variables? Variables means the data which are numerical to start with. Okay, for example, this is the typical example: scores obtained by a student, family size, production of a factory. All these are numeric. That means you can numerically represent this kind of data. So these are variable. However, there are certain other characters which are not expressed in numerical term, but definitely you can make them classified in a suitable fashion. Okay, for example, you can consider the sex of a newborn, or you can consider the language in which the book is written. For example, if you consider the sex of a newborn, or for the matter of, if you consider the, say, again, in our adult average income of this adult in Kolkata, definitely there are some people who are male, some people are female. So you can assign 1 who are female, 0 who are male, and this is the way you can actually categorize, or you can actually classify the characters which are not expressed in typical numerical term. Okay, so this is another distinction which we make. Then there is discrete variable versus continuous variable. Okay, there are some variables which can take only certain isolated value. For example, the number of members of family or the family size. This is a very common variable which we consider while doing different research or while addressing different research issues. Now, definitely family size cannot be 2.6. Okay, it should be either 2 or 3 or 5 or 10, something like that. But apart from that, you have some variable which are continuous in nature. That means the character which may take any value within its range of variations. For example, the price of a commodity, for example, the height and weight of a person, which is very much important in the context of, say, the malnutrition kind of research. For example, we are interested to know the stunting children or something like that. So in that case, definitely the variables with which you will be dealing with, these are the examples of continuous variables. Now coming to the part of, so these are the different the data which may vary with the nature of the data which may vary according to those aspects. Now let us consider the kind of presentation of data. Now definitely one typical presentation is textual presentation of data. Examples are official reports. Apart from that, you may use a particular table to represent the data, but unfortunately, although these things are very familiar, or all of us are familiar with this kind of thing, but when we examine different MPhil or PhD theses, unfortunately, it has been observed that many of us, we do not know how to properly represent the data in a particular tabular form. Even a table, it actually has a certain specific format which we need to follow in order to represent data in a proper way. And apart from that, there are various diagrammatic representation of data. I'll just give you a glimpse of some of these diagrams. These are some of the most commonly used diagrams. Line diagram, ratio chart or semi-logarithmic chart. These are mainly used in economics. Bar diagram, multiple bar diagram, statistical map, pie diagram. So these are some of the typical examples. For example, if you consider the leftmost figure, so this is basically, suppose this is the literacy rate of 3 different states of India. Okay, so that means these columns or bars, they are representing the percentage of population who are literate in that particular state. And apart from that, this is known as the multiple bar diagram. So obviously here the two different bars, they are representing to different ways. This is basically the examples of the number of hours which people spend, the average number of hours which people spend in watching TV and in doing certain kind of household homework in 5 different countries. Okay, so this is basically an example of multiple bar diagram. An classic example of pie diagram. Suppose you have informed, or suppose you are doing a survey of 500 odd respondents, and you want to know their political affiliation. Okay, now this is an example which is there in a statistics book. Now suppose after doing the survey, it appears that some of them they are the supporters of Republicans, some of them they are the supporters of Democrats, and some of them are independent. So obviously, considering the total number of respondents, you can definitely calculate the percentage of respondents who are supporting Republicans or Democrats or independents, and accordingly, if you can put them, then the base diagram to represent this is known as the pie diagram. So here, definitely you are in that in that particular sample, 45% of people they are representing Democrats and so on and so forth. And the last is the line diagram. So here in this axis we are measuring year, and in this axis we are measuring crimes per 1 lakh people. Now obviously, for example, while doing this kind of representation, now this crimes per 1 lakh people is very important, because suppose you want to in the context of India, suppose you want to compare the incidence of crimes among the different Indian states. Okay, now if you just consider the number of crimes which have been done or which have been occurred in a particular state, and then just put the figure, then it is erroneous, because the states are different, the population size of the states are different, and if the population size of the states are different, then definitely the states with higher population, they may end up with a higher number of incidents of crime reporting. Okay, so in order to make the number of incidents of crimes comparable across all states, it is generally done to represent the crime rate per 1 lakh population or per 10,000 population or per 1,000 population, so on and so forth. Again, this is a class. So here, so this kind of things, and these are the different years. So that means here, this is the way you can represent your the incidence of crimes in a particular country over the different time points. So these are the different diagrammatic representation. Now let me come to the different measures which we generally consider for analyzing the data. Okay. Now, while analyzing the data, as I mentioned, like there are different kind of data which we generally observe. One is, as I mentioned, one is called categorical, which is again known as attribute. So if your data is attribute, then how can you represent the data? Now this is the way we can represent the data. This is known as the frequency distribution. Okay, suppose you are doing a survey on a particular manufacturing units which is producing a bulb, and you are interested to examine the quality of the bulb which is produced in that particular manufacturing unit. And for that you took a sample of you take a sample of 60 bulbs, and then you have found out that 11 out of those 60 bulbs they are defective and 49 they are non-defective. So here what are the two attributes, or what are the two qualities which we are looking at? One is defective bulb and another is the non-defective bulb. And what are the number? That is the frequency. The frequency of defective quality is 11. The frequency of non-defective quality is 49. If you add them up, it will be 60. And correspondingly, you can represent, or you can think of relative frequency, which is defined as frequency of the class divided by total frequency. And if you multiply it by 100, then definitely you'll be getting the percentage of bulbs which are defective in nature and the percentage of bulbs which are non-defective in nature. And if you can get that percentage figure, that you can represent those percentage in terms of bar diagram or in terms of pie diagram. Now, this is a distribution in case of a discrete variable. Okay, so discrete variable means variables which can be measured numerically. So when a variables can be measured numerically, then definitely that kind of representation will be a bit different. Different in the sense, here you see we are considering typical examples of a number of which are made through an exchange per minute interval. Okay, and suppose we are considering 92 1 minute interval, and we are trying to find out in 92 1 minute interval how many calls are made. Okay, so for example, how can you interpret this particular table? The interpretation of this particular table means, suppose you are considering 2 and you are considering 13. That means out of these 92, there are 13 such one minute intervals where 2 calls are made. If you are considering this figure 23 and 4, then what does it imply? What do these figures imply? These figures imply that there are, out of 92 1 minute interval, there are 23 such 1 minute intervals in which 4 calls were made. So these 23 is the frequency of the value of the variable, which is equal to 4. Okay, so this is how generally we can interpret the frequency table when the variable is discrete in nature. Accordingly, we can calculate the relative frequency by the same.
Excuse me, sir.
Yes,
Can you
please.
just explain this table once again, like the number of calls and the relation with frequency?
Okay, what I'm trying to say is that this is this is a discrete variable. What is a discrete variable? Because here we are considering the number of calls which are made in 1 minute interval. So we are considering 92 such 1 minute intervals. Okay, and then we are saying, now suppose you are seeing that, suppose what is the interpretation of the third column? The interpretation is something like this. Out of 92 1 minute intervals, there are 13 such 1 minute intervals in which 2 number of calls are made. Okay, or if you consider this 21, what is the interpretation of this frequency? The interpretation of this frequency table is that out of 92 1 minute intervals, there are 21 such 1 minute intervals in which 5 calls are made. So that means the number of calls made, which is equal to 5, is happening 21 times in this particular example. So here we can see that the value of the variable 5 is occurring with a frequency of 21.
Yes, sir, understood.
Is it?
Yes.
Okay. Okay, fine, thank you. And with this, you can definitely calculate the relative frequency. Relative frequency is basically the same way you can calculate this is the same formula for calculating relative frequency, frequency of the class by total frequency. For example, what is the relative frequency corresponding to 21? The relative frequency corresponding to 21 is 21 by 92. Okay, and apart from that, here we have also mentioned two other frequencies which you generally observe in a particular table. One is as the cumulative frequency which are of less than type, and cumulative frequency which are of greater than type. Okay, now cumulative frequency of less than type means this is the definition. Cumulative frequency of less than type are obtained by taking cumulative total of the frequencies going from the lowest value of the variable upwards. Okay, for example, you start with 4 and then you just add the next frequency to get the cumulative frequency up to of less than type. For example, 4, 14, then 27, then 27 plus 21 is 48, and so on and so on. In case of cumulative frequency of greater than type, you need to start with 92, and then 92 minus 4, it is 88. 88 minus 10, it is 78. This is the way generally the cumulative frequencies of less than type and the cumulative frequencies of greater than types are calculated. Now, what is the interpretation? Interpretation is, suppose you are considering, say, this particular figure 40. Okay, what does it imply? It implies that there are 14 such intervals in which one or less number of calls are made. That means you remember there are 92 1-minute interval. Okay, that we are studying. Now, out of this, what is the definition of this cumulative frequency of less than type? We are saying that by 14, it implies that out of 92, there are 14 such 1-minute intervals in which one or less number of calls are made. If you consider, say, 48, what is the interpretation of 48? The interpretation of 48 is as follows. Out of 92 1-minute interval, there are 48 such intervals in which 3 or less number of calls are being made. So this is the way you generally interpret the cumulative frequencies of less than type, and similarly you can always interpret the cumulative frequency of greater than type in a similar fashion. Next, if you that was the case of discrete variable. Discrete variable means there the variables, the number of calls cannot be 1.2. The number of calls may be 1 or 2 or 3 or 4. That means they are discrete in nature. But there are certain cases where the variable is continuous in nature. If the variable is continuous in nature, then definitely the way of representing the frequency distribution would be a bit different. Okay. Typical example, very simple. Suppose you are considering 125 whose heights are there, and definitely their heights are there in centimeters. Okay, now since this is a continuous variable, then that means within a particular range it can take any value. Now, how do you then represent the frequency distribution corresponding to this particular variable? Now, before doing the or representing the frequency distribution, you need to first consider these three facts. Very important. First, you have the frequency classes should be exhaustive and mutually overlapping in nature, which I am going to discuss in the next slide. The number of classes should not be too small or too large. That means if your total frequency is 1000, then definitely 20 to 10 to 20 classes are adequate, and the classes are of equal width if the class frequency is comparable. Now let me explain this. Now these are the class intervals. Now suppose you observe a particular those 125 seeds, the heights of 125 trees, and you observe that the lowest or the minimum height of a particular tree is 6.45 centimeter and the maximum height is 11.25 centimeter. Okay, now you want to represent them in terms of a frequency distribution where the variable is continuous in nature. Then what you need to do? You need to first define a class interval. Class interval means you can define that your 6.45 to 7.25 centimeter, you can define then 7.25 to 8.05, 8.05 to 8.85. Now see that all the class width, that means the difference between the lower class mark and the upper class mark, they are same. Okay, the difference between this and this, they are always same. And they are here. So what is the interpretation of, say, this 5? The interpretation of this 5 is out of 125 trees, there are 5 such trees whose heights are lying between 7.25 centimeter to 8.05 centimeters. Okay, and similarly, by the same way, you can calculate the relative frequency and you can calculate the cumulative frequency of less than type, cumulative frequency of greater than type. So this is the way we can represent the frequency distribution corresponding to a continuous variable. And here, these are some of the important aspects which you need to remember. The 6.45, 7.25, they are known as the class boundaries, and the cumulative frequency of less than type, they generally correspond to the upper class boundaries. This is important because, for example, how do you interpret this 26, this number or this figure 26? This figure 26 implies that out of these 125 trees, there are 26 such trees whose heights are less than or equal to 8.85 centimeters. Now, this is a very simple example of trees. Now, if just you think of this example in the context of a, say, income. Okay, suppose you are trying to look at the income profile of a certain group of people in a particular city. Okay, now then what you need to do, you need to again do a kind of sample survey of, say, 300 people, and then depending on their income level, you can think of certain kind of class intervals related to income, and then you can represent them in terms of this kind of frequency table. That means you can always find out like how many people are there in an income range of, say, between x1 and x2, how many of them are there in the income interval of, say, x2 and x3 and x4, and so on and so forth. Okay, so this is the, and from there you can actually have an overview of the kind of income disparity or income disparities which are there among the people of a particular city. And these are the different kinds of tabular representations which one may use to represent the disparities in income of a particular group of people in a particular city. And the way I have just tried to elaborate or just try to interpret how you can interpret this kind of the different figures which are there in a particular frequency distribution of a variable which are continuous in nature. Okay, now so those are the represent the data in terms of a tabular form. Now I have only already just tried to discuss the frequency distribution corresponding to attribute, corresponding to a discrete variable, corresponding to a continuous variable, and you have seen that the tabular representation and the tabular representation corresponding to the different variables with respect to the nature of the variables, they differ considerably. Now coming to the measures of central tendency. Now, so apart from the tabular representation of data, sometimes as a researcher, we need to understand certain key or the central characteristics of a particular set of data. That's, for example, suppose you want to investigate, say, the political participation of a particular group of people in a city. Okay, if that is the case, then definitely it is not always possible to go to every people and then try to understand their political participation. Okay, so that means you need to now try to find out some measures which can summarize your entire data. Okay, so we require some measures which will describe effectively the most important characteristics of the whole set. Now, one important characteristic we generally use to depict the central characteristic or to describe the central characteristics of a data is known as average. Okay, now average is a very confusing term because there is a tendency to equate average with mean. For example, many of you might have studied this the concept of mean in your +2 level or maybe before that. But most average, there are mean is only one type of average. In fact, there are 3 types of average which we consider, and each of them has their own advantages as well as disadvantages. Now, there are 3 types of averages. One is mean, another is median, another is mode. Okay, so as you see, suppose you have the information or data on the height of a number of school children. So as a researcher, maybe you may be interested to know what is the average height of the children. Now you can do or you can answer this particular question just by looking at either mean or median or mode. Or there are 2 other types of averages which are used in some special cases, which are known as geometric mean and harmonic mean. Now let me just very quickly go through the different measures of central tendency, or how you can actually calculate these measures. Okay, now suppose if a variable is denoted by y, and if there are n number of values of y, suppose values are y1, y2, y3 to yn, then the am is simply the summation divided by the total number of observation. Okay, and this is the case of the data which is without frequency, but there are some cases where the data may come with frequency, and in that case your calculation of am can be done in this way. Now if you are familiar with Excel, then you can easily put your data into Excel, and then you can use this particular formula to calculate the arithmetic mean in case of both the data without frequency and data with frequency. Okay, but but you need to know the formula of how to calculate. For example, if you just considering this particular figure, then what actually it implies, suppose you have, say, information on income of, say, 100 people, that means your n is 100, and your y1, y2, y3, these are nothing but the y1 means the income of the first person, y2 means the income of the second person, y3 is the income of the third person, and yn is the income of the 100 person. Okay, so then you can summarize them and divide by the number of observation, you can get the arithmetic mean. This is one typical example, which is the way the mean is calculated. Now coming to the median. Okay, now again the median is also considered as another measure of average, and in some cases median is preferable to mean as a measure of average. For example, if there are certain extreme values, okay, then definitely if you follow the formula of mean, then and if you incorporate those values into your mean, then there is a possibility that your mean, arithmetic mean, will be affected by those extreme values. For example, just consider this particular formula. Suppose out of this y1, y2, y3, yn, suppose y1, y2, they are extreme values. That means they are in statistics we call them outliers. Okay. Suppose y1, y2, they are distinctly different from the other values. Okay. So if that is the case, then if you apply this particular formula, then there is a higher chance of the arithmetic being influenced by the presence of these two values of the variable y1 and y2. Okay, so if that is the case, then definitely in those cases, arithmetic mean is not a preferred way or preferred measure of doing or representing the central characteristics or the average of that particular series data. Okay, so in that case, median is used. Now, what is median then? The idea of median is for calculating median, you have to arrange y in either increasing or decreasing order of magnitude, and then you have to find out the middlemost value in that particular arrangement, which is called the median of y. Now, this calculation of middlemost value is again a bit tricky. Tricky in the sense your n may be odd, your n may be even. Now, if your n is odd, then definitely n plus 1 by 2th value in the arrangement is the unique median of y. And if your n is even, then there is no unique median. So in that case, you have to calculate the n by 2th and n by 2 1st value, and you have to consider the average of these two values, which is considered as the median. So this is the way generally median is calculated. Again, if we consider the cell process data, that means the data which I have given here. So here we have 10 number of days, and there are cell which are done on those 10 days. So that means you have your n, the number of observation is 10, the number of observation is 5. So what is the median value? Median value is any value which is between 5th and 6th value may be taken as median, and by convention it is the average of those two values. So by the convention, your 94 will be the value of median in that particular case. And if your variable is continuous in there, then you have to calculate the frequency, cumulative frequency, which I have just showed to you in some of my previous tables, and there you have to find out the value corresponding to which the cumulative frequency is n by 2. Okay, this is how generally the cumulative the median is calculated in the context of a continuous variable. Now, this is a common mistake which you generally do in the context of median, calculation of median, when we are dealing with data with frequency. For example, suppose you have a sample of shoe size of a sample of 21 women. Okay, so that means the interpretation of something of this data is something like this. That means there are 5 women whose shoe size are 4. There are 6 women whose shoe size are 5, 7 women whose shoe size are 6, and so on and so forth. So this is basically data with frequency. Now, as we already mentioned that what you need to do, you need to arrange the data in either increasing or decreasing order, and then you have to find out the middlemost value. So here the shoe sizes, they are already arranged in an increasing order, so you have a tendency to mention 6 as the median value. So that is the common mistakes which we generally do. But what you need to understand is the fact that this particular data set is a data set with frequency. Okay, so that means when there are 21 women, so the shoe sizes should be arranged in the order of magnitude. That means you have to find out in this, that means you have to rearrange the entire data in this fashion. There are 4 women with shoe size, sorry, 5 women with shoe size 4. There are 6 women with shoe size 5. There are 7 women with shoe size 6, and so on and so forth. And then you have to calculate the median value. And how can you calculate the median value? Here we are considering 21 women. So here n is odd. So what will be the median value? The median value is n plus 1 by 12. That means the 11th value. And if you just consider this particular series, then your 11th value is not to be 5. So 5 will be the median value, not the 6. So that means when you are dealing with the data with frequency, then definitely for calculating median, you need to be a bit cautious while doing the exercise. Okay, and as I have already mentioned, that the median is a good measure of the average value when the data include exceptionally high or low values. In that cases, that means if your data set contains some outliers, then definitely it would be better to, if you want to use average, then instead of mean, it is always advisable to use the median. Apart from that, there are certain other measures which is known as the method of mode, and as we know, mode is another way of representing the average value. And how mode is defined? The mode is defined as the value of a variable with the highest frequency. Because how can we measure? Just consider this particular example. If you look at this particular example, then you see that all the cell proceeds figure, all of them, they occurred once, except one cell figure, which is 92. Okay, so you see here 92 only, this particular figure comes twice, else all other figures, they only occurred once. Okay, so that means from this particular figure, if you want to find out the average, then obviously from this particular table, what is the mode value? The mode value is equal to 92, because here 92 comes with the highest frequency. That means here 92 occurs twice. All other variables, they occur only once. Okay, so this is how generally mode is calculated in a very easier way. And then what is the advantage of mode? Definitely, when you have some sort of nominal data, then you cannot use the mean, average or the median. For example, suppose you are considering say how many of the students they are using library. Okay, now obviously some of them are science students, some of them are social science students, some of them are biological students. Okay, so obviously you cannot say that okay, this is the number of students which are using science library and social science students that are using library. So what you can do, you can always calculate the percentage of students who are using science, the percentage of science students who are using library, the percentage of social science students who are using library, that's the biological students who are library. Okay, because here when you have the data, means what is the type of data? Type of data means you have the students who either from the science stream or from the social science stream or from the biological science stream. So you are actually put in a numerical value, but that is why this is called the nominal data. That means you can always convert this categorical data into a nominal data by putting certain but assuming certain values. For example, you can assign that okay, there are science students, you may assign 1, social science students you may 2, Biological science students, you may assign 3. So in this way, you can categorize the students, and then you can find out how many percentage of people, how many percentage of students they are from science background and using library, how many of them they are belonging to social science and using library, how many of the students they are from biological science background and using library. Okay, so in this case, definitely you cannot calculate median or mean. Okay, because here you have assigned 1, 2, 3 this figure only, you have assumed this value. Okay, so in this case, preferred mode of representing the average characteristics or the average is by mode. So here, obviously, the mode will be the 50 biologic. The mode is the only measure of the average which can be used in case of nominal. Okay, and this is basically the typical comparison of mean, median, and mode. This is the empirical relation. Now, these relations generally we use in statistics, but any good measure, as you know, it has to be rigidly defined. Any good measure has to be easily computed, and any good measure has to be based on all observation. Okay, and if you consider these three method or these three measures of average, that means mean, median, or mode, then definitely mean will emerge as the best measure, because you have a formula for calculating mean which is rigidly defined. It can be easily computed because the calculation is a bit straightforward, and definitely mean is based on all the observations. Okay, but as I already mentioned that if the data contains few extreme value, then mean should not be used, because there is a high chance of the mean being affected by those extreme values. And another thing is that mean is inappropriate for averaging data which are measured in ordinal scale. For example, you may have some data where higher score in higher rank, and in that case you cannot simply use the mean. Okay, so in that case you have to think of certain other measures of central tendency, for example, mode. And these are the two other measures of average, which is known as geometric mean. And this is the formula for geometric mean. And generally, this geometric mean and the harmonic mean, these are mostly used in not much in political science or other social sciences. So, but again, but still, since these are the two other standard measures of average. So I have just mentioned that you can also you need to be familiar with the geometric mean and harmonic mean concept. Let me come to the measures of dispersion. So this is just let me stop here and like so if there are any confusions or if there are any questions which you may need clarification, so you may ask. Or should I continue?
So if anyone has any questions, then the floor is open. Please go ahead and ask.
Yes.
Sir is waiting for a question. So anyone.
So anyway, I think there is none. So let me continue with my presentation. So you can view now.
Yes, sir, it's visible.
Okay, fine. So let me now move over to the measures of dispersion. So why the measures of dispersion are important? Again, these are very commonly used example to understand the utility of the measures of dispersion. Suppose you are considering the runs which are scored by two batsmen. The batsman one, which is whose score is in the last 5 innings is 55, 50, 42, 57, 43, and batsman 2, 2, 105, 79, 14, and 50. These are the scores of these two batsmen. in last 5 innings. Okay, now obviously if you want to calculate the average, so the average turns out to be 50 for both these batsmen. Okay, but you see from this particular series, it is quite obvious that the batsman won. He puts up a more consistent performance than batsman two. Okay, so what is the upshot of this particular data representation is that average is not sufficient to get an idea about the overall nature of data. Now, until now, I have considered only the average to depict the central characteristics of the data. Okay, but average is not sufficient to get an idea about the overall nature of the data, which is very much obvious from this particular example. Okay, so here, in order to understand the nature of the data, another aspect which we need to focus on is the variability of the set of the values. Okay, now the characteristics of frequency distributions which capture this variability is called the dispersion. Okay, that means there are certain methods or certain measures which are there which can capture the variability in the set of the values and which will give you some important insights into the nature of the data. And these are the four specific measures which are there. One is range, the other one is mean deviation, the third one is standard deviation, which is a very popular, because if you see any research paper which are based on primary data, then you will see that there is a table which gives you the central characteristics of the data with which they worked. And two such central characteristics is, one is average, another is the standard deviation. And the fourth measure is the quartile deviation. Okay. And what is the range? Range is the simplest measure of dispersion, and it is simply defined as the difference between highest and lowest value of a given given values of a variable. Okay. And the next one is mean deviation, and mean deviation is calculated in this fashion. That means if you consider, suppose these are the different values of a particular variable, and if A is the average value of Y, then yi minus A is the deviation of the value from Y from the average. So obviously from here it is quite clear that the larger the deviation, higher is the dispersion of Y, because what is yi? A is the average value, and A is the average value, and yi is the origin value. So higher is the larger are the deviations, higher is the dispersion of Y. Okay, and if you consider the simply if you consider the aim of or the average of this particular figure, then what will happen, that there are some values which will be negative, there are some values which will be positive. So there is a possibility that positives, they are cancelling out the negative values. Okay, so obviously in this case, for calculating the mean deviation, we, instead of using the simple aim of deviation, we use this for a formula where this is nothing but the absolute value. It means your negative value now turning out to be positive value. So this is how the mean deviation is calculated, and this is the calculation of standard deviation. And one can easily, if you have data, if you can if you put your data into an Excel sheet, then definitely you can use this particular formula to calculate the variance of ungrouped data and also the group data by using this formula. Okay, and this is one specific example which we have, which I have just mentioned to show you how you can calculate the standard deviation corresponding to a particular variable. This is quartile deviation is another important aspect or measures of dispersion, and here there are three different quartiles which we generally consider. One is known as the first quartile. First quartile is the value of the variable such that the 1/4 of the given value are less than or equal to it, and the remaining 3/4 greater than or equal to it. And the second quartile is the median, that means the middlemost value, and the third quartile is the value of the variable such that the 3/4 of the given values are less than or equal to it. And quartile deviation is defined in this fashion: Q3 minus Q1 divided by 2. Okay, and if you consider these different measures of dispersion, then again, depending on certain measures, you can say that the standard deviation is regarded as the best measures of dispersion. Okay. Now, apart from this, there is another very interesting dispersion which generally as a researcher we need is the measures of relative dispersion. Okay, because the measures of dispersion which we have just discussed, they cannot be used to compare the variability of the distributions of the variable of two different types. Suppose you are interested to know the variations which are there in a group of students and their heights and their weights. Now generally what happens is that the heights are represented in inches and the weights are represented in kgs. So if this is the case, then definitely you cannot compare the variability in the heights of the students with the variability of the weights of the students. Okay, so in order to make them comparable, you have to make these variables unique. Okay, so in that context, your coefficient of variation is very much helpful. Okay, and the coefficient of variation is defined in this way. It is defined as 100 into standard deviation by mean, and where standard deviation and mean, they can be calculated the way I have just mentioned. Okay, and how can you interpret the variable with the higher CV? It has the greater variability. In fact, just to correct my previous slide, we can also see that the coefficient of variation is also useful to compare the sets of data which are expressed in same unit but having widely different means. Just consider the length of rod. There are, suppose you are measuring the variability in two types of rods, one of length 10 centimeter, other of length 100 centimeter. So if that is the case, then definitely in case of first group of rods, the mean will be 10, and in the case of second group of rods, the mean will be 100. But in this context, the standard deviation may, suppose you apply the formula standard deviation and it turns out to be 2 centimeter. Okay, but the problem is standard deviation of 2 centimeter in the context of first case, it is not the same thing as the standard deviation of 10 in the context of second. So here, if you want to get the extent of variability which is there in these two groups of observation, then you need to actually compare them using the CV. Okay, so that is where the basic use of the relative dispersion lies. And apart from that, in order to understand the nature of the data, we also use certain measures of skewness. And by skewness of a frequency distribution, we mean its departure from symmetry. Okay, and let me just show you the figure of a symmetrical distribution. Symmetrical distribution means the distribution is symmetric with respect to means the frequency which are there in the left hand side, they are same as the frequency of the right hand side. This is the figure of a positively skewed distribution. That means here there is a tendency of higher values to the lower, to the higher end of observation, and this is the distribution of a negatively skewed distribution. And apart from that, another measure which is used, which is known as the measure of kurtosis. Okay, and by kurtosis we generally imply the degree of thickness or steepness of a frequency distribution, and there are three types, which is known as mesokartic, leptokartic, and platykartic. And these are the different examples of the kurtosis measure. And these are very standard measures, but these are not generally that much of utilized in the context of analysis of data. Analysis of data which are used in the other social science streams. So you may be better off if you can understand the measures of central tendency and the measures of dispersion. Okay. Now coming to another very important aspect, and this will be my the last impact, but I'll be stop at correlation analysis. The data which we have considered so far is univariate in nature. That means we have considered only one particular data. Okay, but in some cases, in many interesting cases, we may need to deal with the bivariate data, and we may be interested to see or to get the relationship between those two different variables. Okay, for example, you may be interested to know the relationship between age and blood pressure for a group of people, or you may be interested to know the heights of fathers and adult son for a group of families. Okay, now in this case, definitely you need to perform certain analysis to understand what is the nature of relationship between these two different variables. Okay, now generally there are two types of bivariate analysis. One is called correlation analysis, another is called the regression analysis. Okay, and what is correlation analysis? There is a difference between correlation and regression analysis. Correlation analysis is basically a joint relationship between two variables, and it is a measure of interdependence, which is called the correlation coefficient. And in case of regression analysis, there are two variables. One variable is regarded as the independent variable, and the other variable is regarded as the dependent variable. And in this case, the dependence of the variable y on the independent variable x is investigated. Okay, this is basically the idea of regression analysis. And but generally, let me today regression analysis is again a very huge area, so that's a different literature altogether. So let me just concentrate on the methods of studying correlation. Okay, now while studying correlation, definitely there are two methods. One is graphical method, which is done using the help of scatter diagram, and there are algebraic method. For algebraic method, we use the Karl Pearson's coefficient of correlation. Now let me explain these two methods. Scatter diagrams, it's a very simple thing. Now it's the graphical method of finding out the relationship between two variables. And suppose you have data on x, you have data on y. Now definitely corresponding to each observation or each individual, you have data on both x and y. For example, if you consider the relations, or if you are interested to examine the relationship between age, between say the age and blood pressure of a particular group of people, then definitely corresponding to individual 1, you have the information on his age and the blood pressure. For individual 2, again you have information on his or her age and blood pressure, and so on and so forth. That means corresponding to every individual, you have one pair of x and y values. Okay, now if you plot that pair of xy value in a typical graph, then the figure that you get is known as the scatter diagram. Okay, and generally it is said that the greater the scatter of points over the graph, the lesser is the relationship between the variables. And these are the different possibilities which we generally consider in the case of a scatter diagram. For example, this is known as the high degree of positive correlation. So all these scatter points are corresponding to a particular group of people. For example, if you consider this scatter point, what does it imply? It implies that suppose this is representative of this particular individual. So corresponding to a particular individual, he has a particular pair of x and y values. Okay, now high degree of positive correlation, what does it imply? It implies that this is the interpretation. Now, if there is an increase in the value of one variable, the value of the other variable is also found to increase. So, if that is the case, then you say that the variables are positively correlated. So, how this is basically a graphical representation of the variables, two variables which are positively correlated. Why? Because you see here, with the increase in the value of x, there is also increase in the value of y. Okay, so that is why the correlation which is between these two variables is considered to be positive correlation. And if you consider this particular data, then what you see, if you with increase in the values of x, there is decrease in the values of y. Okay, so that means you are actually witnessing a situation of high degree of negative correlation. Okay, and this is case of perfect positive correlation. Why it is called perfect positive correlation? Because here through these scatter points you can think of a specific straight line. Okay, that means corresponding to every increase in the value of x, there will be an increase in the value of y. Similarly, this is the case of perfect negative correlation. Okay, and this is the lower degree of positive correlation. This is the higher degree of positive correlation. Why this is low and why this is higher? Because if you consider a particular straight line, then definitely corresponding to this figure, you can draw a straight line, but you see that the points are scattered with respect to the particular straight line. So that is why it is representative of a case of lower degree of positive correlation. But if you consider this particular figure, then if you can draw a straight line through it, then you can see that the scatter point, they are more or less, they are concentrating on and around that particular straight line. That is why they are representing higher degree of positive correlation. That is why here I mentioned that the greater the scatter of points over a particular graph, the lesser is the relationship, the lesser is the strength of the relationship between the variables. That is why there is a concentration of the points corresponding to a particular straight line. That is why this particular figure is representative of high degree of positive correlation, and this particular figure is representative of low degree of positive correlation. Similarly, if you compare these two particular figures, so here it is representative of low degree of negative correlation, but this is representative of high degree of negative correlation because of the same reason. Here, the points, they are concentrated more closely to a particular straight line, but here the points are scattered with respect to a particular straight line. And here, you consider these scattered points, then definitely there is no correlation, because here, from just by looking at this particular picture, you cannot say conclusively that corresponding to increase in x, that y will decrease or y will increase. Here, if you just consider this particular figure, here corresponding to increase in x, you can say conclusively that the y will also increase. Or if you consider this particular figure, then here with increase in x, you can say conclusively that y will decrease. But here, no such conclusive thing is there. That means here corresponding to increase in x, y may increase, y may decrease. Here also corresponding to increase in x, y may decrease, y may increase. That means there is no correlation between x and y. This is what we actually I have just summarized the entire thing here. That means here what we have said, that the nearer the points are to the straight line, the higher is the degree of correlation. In many research papers, even in your field, you will see this kind of scatter diagram representation of a group of data. Okay, and now this is basically the graphical representation, and this is the mathematical or the algebraic representation. This is the formula for calculating correlation coefficient, where correlation coefficient is defined as covariance between x and y divided by standard deviation of x and standard deviation of y, and it has got very nice properties. The pure number, and it must lie between -1 and +1. If it is equal to -1, that means it is, but the two variables are perfectly negatively correlated. If it is equal to +, that means the two variables are perfectly positively correlated. Okay, and however, in spite of all these all these values of the correlation coefficient, there are some serious limitations of R, and that is why we need to learn the regression technique. The limitations of R is that R is a satisfactory measure of the strength of the relationship between two variables, but that relationship holds only when the relationship is of linear types. Okay, because when our correlation coefficient value is low, it does not rule out the possibility of other relations. Okay, that means if in a particular analysis, if you find out that your R square is equal to 0, then just going by previous formula, you can say that if R square is equal to 0, that means there is no correlation. You may be tempted to say that since your R square is equal to 0, or if your R square is low, the relationship between the two variables is weak. That should not be the case, because it can be shown, which is very much clear from this particular example, that R is a satisfactory measure of the strength of the relationship between the two variables only when the relationship is of linear type. Because if you consider the two variables x and y, where x are taking the values like this and y are taking the values like this, if you just take a close look of these two variables, then you can see that one can represent the relationship between the two variables in this format, that y is equal to 10 plus x square. If you just put the values of x square, put the values of x's, then you will see that y is following this particular representation. But if you calculate the R square by previous formula, that means the formula which I have discussed here, then your R square is turning out to be equal to 0. Okay, so your R square is 0. That means the two variables, there does not exist any linear relationship between the two variables, which is quite clear from this particular expression, because here the relationship between the variables is not linear in nature. Okay, so that means the R square can be used as a satisfactory measure of strength of relationship between the two variables only the relationship is of linear type. And another important aspect is that the two variables correlated does not necessarily mean that they are causally related. Why? Because suppose you have data on say high school population and the volume of exports. Now obviously one can easily understand the fact that there is no relation between the high school population and the volume of exports. Okay, because exports is related to countries' this economic condition, and high school population is basically related to a say educational aspects. Okay, so but you may find out that R between the two time series, they are high. Okay, so if that is high, the two variables correlated, that does not necessarily mean that they are actually correlated, because the cases when the high R square is because of the same underlying trend between those variables, then we have a particular case of correlation, which is known in the literature as the case of nonsense correlation. Okay, so that means when you are using R square or the correlation coefficient for understanding the relationship between two different variables, then you have to keep in mind these two serious limitations of the correlation coefficients. Limitation number one is this R square will describe the relationship between the two variables only when the relationship is linear in nature. And second, the two variables, they may be correlated with each other, but that does not imply that they are causally related. And if that is the case, then we may encounter the situation of nonsense correlation. Okay. And apart from that, there is another correlation coefficient which we use. This is known as the rank correlation coefficient, because in many qualitative research, you may find that it is possible to arrange a number of individuals according to a degree which they possess a given character. That means these are qualitative in nature. And in that case, you can actually make a kind of ordered arrangement which is called ranking. Okay. And when you can rank both the variables according to a particular attribute, which is very much there in the context of qualitative analysis, then the association between these two series of ranks is called the rank correlation. This is how generally the rank correlation is calculated. This is the formula for calculating rank correlation. Again, if you have the data on your attributes on your qualitative variables, then you can easily use this particular formula to calculate the rank correlation. And these are the different uses of rank correlation. One, you can use the degree, or you can find the degree of association between the two series of data which are given as rank. You can find out the correlation between the two qualitative characters which are amenable to ranking, and you can also measure the agreement between the rank assigned by the two judges when same set of individuals with respect to the same character. Okay, so these are the different. So rank correlation coefficient is something different from the normal correlation coefficient. Rank correlation coefficient is only applicable when you have, or you can assign some sort of ranks to a data with which you are working. Okay, so let me stop here, because these are some of the very basic issues which I have tried to cover in today's lecture, and basically this will be might be helpful for you to analyze the nature of data, to make a to collect. It will be helpful for you to for your collection of data, for tabular representation of data, and to analyze some of the basic characteristics of data. And this is basically the reference which you may look at. You may look at the first two references, because the third reference is applicable for the regression analysis, which I have not covered today. So if you are interested, you may have a look at these two particular books. One is Fundamental Statistics. This is a very famous book by A.M. Gund, N.K. Gupta, and B. Dasgupta. And the third one, the second one, it is basically a Statistics in Plain English. It is published by Tillman Francis, Timothy C. Udan, and the first book is purely for students of statistics. So you may find this book a little bit different, but you may, if you want to apply some of the statistical measures for your analysis, then you will look at this particular book, Statistics in Plain English. So it might there are lots of examples which might be useful or helpful for you to use some of the measures which I have discussed in my today's presentation. And this is my email ID. So in case if you have any queries, you please feel free to reach me at, or drop me an email to this particular address, so that If you have any queries, I can take up those queries. Okay, so thank you very much for your patient hearing. So that's all from my end. So now it's over to you, Nilanjan.
Thank you so much, sir. I will just ask if anyone has any questions or anything, then I guess we can take those questions if anyone has any.
Yes, sir. I have one question related to sampling.
Yes, yes,
Yes. Just beginning with an crude example, that if I am studying the voting preferences of a particular community in a district, so I may not go on collecting, the entire population of the district. It might not be feasible. So I might be taking certain samples, like certain villages or so. So, what are the factors through which we can decide a sample size? This was my question.
this decision regarding the sample size is definitely now there are certain statistical measures which we generally use to decide on the sample size, but I think much more important for you to decide on the sampling frame. Okay, because for example, when you are taking these voting preferences and you are concentrating on a particular community, then the selection of village that your unit is going to be very crucial. Okay, so in
Yes.
that case, the selection of village should be based on certain characteristics. Okay, for example, you may consider the selection of village based on certain socioeconomic characteristics. For example, we use literacy rate for selection of village. Generally, we consider the villages with higher percentage of literate people to be developed one as compared to the villages with lower percentage of literate people. So this is one example. Another, and this information you can get from your census data. Another very example, very interesting indicator which we generally use to look at the backwardness of the village is the percentage of SC/ST people in the particular village. Because generally it is generally assumed that the higher the proportion of SC/ST people, greater is the degree of backwardness of the particular village. So you have to first select that particular village, and then I think in that case, within that particular village, if you are concentrating on a specific community, then corresponding to that community, you can definitely you can have an idea about the entire population. Okay, and then you can either go for random sampling or you can go for representative sampling. Now, random sampling, I think there are some practical problems with random sampling because it is very difficult to ensure the randomness of the sampling units which we collect. Okay, so as an alternative, you can think of a representative sample. That means you are uh, examining a particular community. So what you can do, again, corresponding to the particular community, you may consider taking their principal characteristics. Principal characteristics. For example, you may consider their male-female proportion. You may consider their level of working status. For example, in census, I'm not sure whether you are familiar with the census data or not, but nowadays students across the social science discipline, they are using the census data. For example,
Yes, sir.
in
Yes,
census
sir.
we have two different categories of workers. One is main workers, another is the marginal workers. Okay, so you may consider the proportion of main workers in that community, proportion of marginal workers in that community. Okay, so then if you have the idea about the proportion of male female and the proportion of say main workers and the marginal workers, then you can suppose you decide on a sample of 100. Okay, then within that 100 you may want to ensure that within 100 the proportion of male workers which is representative of the population should be represented in your sample. Say in the community in which you are interested, suppose within that community 60% of them they are employed as main workers and 40% of them they are employed as marginal workers. If that is the case, and if your sample size is 100, then you need to choose the sampling units in such a way so that out of those 100 people, 60 of them they are employed as main workers, 40 of them they should be employed as a marginal worker. So in this way you may ensure the randomness of your sample. Okay, you may
Yes, sir.
also think of their educational status. Okay, because all these data are very much easily available from the census. So you may also use education as another important variable to decide on your sampling frame. So these are the different techniques which generally we follow to decide on our sampling units and to choose the sampling type. Okay, and
Yes,
random
sir.
definitely,
Thank
and
you.
if you can do the random sampling, then definitely you are free to do that. So that's the best way to ensure randomness.
Okay, sir. Thank you, sir. Very helpful, sir. Very helpful tip.
Okay, thank you so much. Yes, any other question?
So, sir, I think we don't have any more questions left. So, it was
Sure.
indeed a very enlightening and enriching session, sir. Your thoughts and insights have been impactful. Thank you for being here with us today. I thank everyone present in this session. Now, we may conclude the session. Thank you, sir, once again.
Thank you so much. Yeah. Thank you so much and good night to all of you.
Yes, sir, good night.
Thank you, sir.
Thank you.